So we are solving cubic inequalities. Let's zoom in and look at the question we are facing. Whenever you're facing a question like this, the best thing you can do is decipher what it's saying, write it in plain English. So it's asking us to solve this for when it is less than 0. So what it's asking is when is, oh, that's a bit thick, isn't it? Let's try again. When is this function right here? When is this function, and now what I have is a less than 0. So what that means is when is this function below the x-axis, So this is really helping us understand what the question is asking and visualizing it as well. When is this function below the x-axis? So let's zoom out and get all the important information. The first thing that we're going to have to do is figure out what our x-intercepts are going to be in order to give this a sketch. So to find the x-intercepts, we can easily do this using our null factor theorem, which is going to be 2, it's going to be -1, and it's going to be 3. So I'm just setting each of these equal to 0 and then solving for x, realizing that if I were, for example, to put 2 into my x spot here, I'm going to get 2 minus 2, which is 0. So therefore the whole thing goes to 0, which means it's an x-intercept. So let's now put that piece of information on our graph. So I'm going to get -1. I'm going to get, let's make that a bit further away. I'm going to get 2 and I'm going to get 3. So those are my x-intercepts. Now, before I can begin to sketch this, I need to figure out whether or not I'm going to be drawing it like this, going up, then down, then up, or whether or not I'm going to be drawing it like this, going down, then up and down. I know it's a cubic, I just don't know which is which at the moment. So what we do is we're going to consider what would our sign be of our x cubed if we were to expand this. Now let me remind you, do not expand it. You'd be wasting your time. Do not expand it. But we need to figure out whether or not I'm going to get a positive x cubed, which would mean my graph would look like this, go up, then down, then up, or is it a negative x cubed, in which that would mean I'm going down, then up, then down. To figure this out, we just need to consider the fact that up here, this is positive, and this is positive. So if I were to multiply them all together, it's obviously going to be positive. So I can come now and I can draw this. So it's going to go up, then it's going to go down. Oh, that's ugly. Let me try again. It's going to go up, then it's going to go down, and then it's going to go up again. Now that isn't the prettiest graph in the world, but I'm actually going to leave it because it doesn't need to be the prettiest graph in the world because this isn't our answer. It isn't our answer. It's just helping us figure out what our answer is going to be. Now I've just written a few other things down here. The first of which is we do not need to find the y-intercept. Again, the graph isn't our answer. So it would be wasting our time to find the y-intercept. And then we have to ask ourselves, well, now we have to highlight the relevant areas. So let's do that. Let's get the highlighter out. And remember, it's where it is below the x-axis, So I'm below the x-axis here. So let me highlight that. And I'm below the x-axis here. So let me highlight that as well. I've also written here, do you include the x-intercepts? That's very important to consider. Do I include the x-intercepts? And the answer to this is no, I do not include the x-intercepts because it simply says below the x-axis. It's just less than 0. It is not less than or equal to 0. It's just less than 0. So if you wanted to remind yourself of this, you could put open circles here to remind yourself that you're not including them. That's a big mistake that people make. So putting open circles can just help you remind you of that fact. Then what we're going to do is actually write down our answer, remembering this isn't our answer. So let's now write down our answer. We can do it in two ways. We can use inequalities or we can use interval notation. Let's begin with inequalities. So it's going to be, well, this right here would be x is less than -1, or to represent this region right here, it would be 2 is less than x is less than 3. Let's appreciate the fact that I have not put or equal to here. It is just a less than, and that's because it's just less than here. I can also write this in interval notation, in which I would say where x is an element of, and to represent this region, I would have an open circle, -infinity, all the way to -1, and -1 will also have an open bracket, circle, open bracket, because I'm not including it. And then there would be the union of 2 to 3. Again, open brackets because I'm not including them. Let's put a square. Let's put a red square around our answers because they're our answers and they're very important. So a red square like that. I'm just failing at drawing these lines. There we go. So hopefully this has made sense to you. And let's just, before we end, just reflect on the fact why we don't have to find the y-intercepts. Because if you look at our answer has nothing to do with the y-intercepts. So therefore, it doesn't matter. It doesn't matter how high my graph is above or below the x-axis. What only matters is that it is. So for instance, if I was to draw this like this instead, to go really far down, well, that's pointless. It's still below. We don't care. And if I was to draw it really high up, it doesn't matter because we know we're not going to consider it anyway because we're only considering things below the x-axis. So the magnitude by which it is above or below is irrelevant. So don't waste your time trying to figure out what the y-intercepts are or figuring out how low you need to go. It's not important. So there are your answers. Hopefully this video was helpful to you, and I'll see you in the next video.